Hello, my name is Nick Atkins, and today I will be starting a new YouTube video series that I've been wanting to do for some time, and that is a series on differential equations. So what I'm effectively calling this course is Review of Differential Equations. And just to reiterate, my name is Nick Atkins. And of course, you can see that from the channel name, but it's nice to repeat it. So let's talk about some of the types of things I'll be covering in this course, like a basic outline. So first of all, before we can even start doing true mathematics, we need to talk about what is a differential equation. And this is very important because a lot of things with differential equations really are conceptual, and it's really important to have a conceptual view and qualitative view of what you're studying rather than just plugging in numbers. And that's important, but that's not the entire story. So that's a very important question. Next, we will be going into really the beginning. We'll be going over basic differential equations, and that'll cover stuff like an intro to direction fields, initial value problems, equilibrium solutions, and stuff like that. So after that, we will finally get into what we call first order differential equations. This is really, well, I guess for a lot of people, this is really maybe the hardest part of differential equations, because first learning like how to think about numbers and how to think of these equations and see the general approaches to each, that's really important, and this is where you first encounter these ideas. So after this, we'll be doing first order differential equations. I already said that, but as an aside, what will be in here is many different ways to solve first order differential equations, as well as autonomous differential equations and the existence and uniqueness theorem, as well as applications. And applications are why differential equations are here in the first place. So next, after that, might seem pretty natural to go to what we call second order differential equations. And we will get into what these mean in due time, but just know this is the logical progression. So after here, we don't go to third order differential equations, really. What we call them is we call them nth order differential equations. And this is just differential equations where the power of the derivative is greater than 2. So after that, we might go a couple different ways. So I'm thinking about possibly doing power series solutions, but maybe not. In my view, the next logical step from this is systems of differential equations. But from here on out, I'm going to start calling differential equations ODEs, and that stands for ordinary differential equation. Just keep that in mind, it's a little bit of terminology. So we'll go over systems of differential equations, and part of that will be a little bit of linear algebra review, and part of it will be some applications and modeling. So after systems, we'll probably go on to nonlinear differential equations. Never ODE, but that's fine. Nonlinear differential equations, and including this is stability. And this is very important because stability really deals with the qualitative view of differential equations, not the quantitative. So next after this, probably to get much more to the applications, we might even see some coding examples where I do some code, will be numerical approximations. Because differential equations are used so much in the real world, and oftentimes when you have differential equations, you often have many of them, like constantly changing like airflow patterns or different things governed by differential equations. When stuff is changing very quickly, you need very many to describe that system, and to get solutions, sometimes you can't always find them analytically, and computers don't solve differential equations analytically and then plug in numbers. So numerical approximations are very important. So after that, sorry, that's not, I do 8, 9. After this, we can probably go to, yeah, if we have time, we can do series solutions, which is also pretty important, although it's a little bit higher level than some of this other stuff. Although it does require very good knowledge of Calc 2 and power series and just series in general. And then after this, if we have time, and this is a topic I myself yet haven't covered, but I plan to this summer, is Laplace transforms. Cool. And also, because I'm doing this class, I will not only do a video series on each one of these topics, but also include practice problems and solution sets, and I might even go make a couple videos on old homework sets that I've turned in. We'll really see what happens, but I plan on giving you guys a whole lot of practice problems and a whole lot of exposure to this. Also, you can contact me at my email, which for IU is nratkins@iu.edu. And as well, I will start uploading lecture notes and practice problems and all sorts of stuff to my website, which is not fully operational yet, but soon will be, and there'll be a lot of resources on there. So yeah, I believe that's everything. I'll see you in the next video for what is a differential equation and just basics to differential equations. Thank you.